Hi folks, we're going to take a look at page 233, numbers 12, 13, and 14, and essentially this is just the development of what are called the double angle formulas. Probably the trig identities you're going to use the most over the years. Okay, so when we're talking about double angle, so here we're talking about determining an expression for sine of 2a, okay, and determining expression for cosine of 2a. Okay. So let's see how we can do this, and we're going to see we can use a similar procedure in both. Okay, so because we have an addition formulas for both sine and cosine, I'm just going to rewrite 2a as sine of a plus a. Okay, and now I'm just going to apply the addition formula for sine. Okay, so the addition formula goes something like this. So again, if you want to name these two different letters, but as you've seen, I like to just think about the order here. Okay, so the formula goes sine of the first, which is just sine A, times cos of the second. Okay, plus sine of the second, which is still sine A, times cos of the first, which is still cos A. So we see that these two expressions are in fact exactly the same. So this can just be written as 2 sine A cos A. Okay, so first thing to notice is that sine 2a is not equal to 2 times sine A. Okay, so while that would be a nice property, that's not correct, but it is equal to something relatively simple. Okay, so there's your double angle formula for sine. Okay, so now I'm just going to do the exact same thing for cosine. I'm going to rewrite this as cosine of a plus a. And so now I can rewrite this using the addition formula for cosine. And again, I'll go by thinking of the order. So the rule says that this is equal to cosine of the first times cosine of the second. But of course, the second angle is exactly the same. Okay, minus sine of the first times sine of the second, which again is exactly the same. So here we see that the cosine formula is just, or the cosine double angle formula is just cos squared A minus sine squared A. Okay, now be careful, don't confuse this with our Pythagorean identity, which is sine squared plus cos squared equaling 1. Okay, but speaking of that identity, if you look here, I got a cos squared, I got a sine squared, and that Pythagorean identity which I just talked about, so sine squared A plus cos squared A equaling 1 might come in handy here, because what I can do is wherever I see a cos squared, I could replace it by 1 minus sine squared, and so my expression only has sines in it. Or I could do the same thing with the sine, replace sine squared with 1 minus cos squared, and so my expression contains only cosines. Okay, and this is what I meant when I told you that there were 3 versions of this double angle formula. So this is version 1, okay, which is sometimes very useful, but the other 2 versions, okay, so let's start by replacing sine squared by 1 minus cos squared. So here we have cos squared A minus, and I'm going to replace sine squared by 1 minus cos squared A. Okay, and so here I have cos squared plus cos squared A, okay, because I'm subtracting a negative, so that gives me 2 cos squared A, and then minus 1, okay, and that's my second version of the double angle formula. And my third version, okay, is I'm going to do something very similar, except I'm going to replace cos squared by 1 minus sine squared A, okay, minus that other sine squared A which is in the formula, and so here we have 1 minus, okay, and here, because we have negative sine squared minus another sine squared, so this is minus 2 sine squared A. Okay, and again, what's nice about these 2 formulas is you have this given as an expression only including sine, cosine here, and only sine there. Okay, and we're actually going to see that this is going to turn out to be useful for us very soon. Okay, so again, if there's any of these identities that you should probably start to learn by heart, it's probably these 4. These are the ones that are most commonly used in what we're